Geometry creation requires some decomposition. So I have to decompose geometry. So you can see here. Number one thing is that I have click on the rotate, and I actually put the rotate command, body transformation and rotate. So what I did is that initially geometry was at the like the plane we were cutting here was along the x-axis. So geometry looked like it was on the x-axis and then some angle there. Okay. So if I don't use this command, like suppress everything there, geometry was here. This is what this is what I'm talking about. So this is along the z-x plane, one side, and then we have the angle here. Okay. So like if you display from xy plane, this will look like in this way. This thing. Okay. So I just like rotate it by 75 degrees so that it goes on the middle of the 15 degrees on the right side of the y-axis and 15 degrees on the left side of the y-axis. Okay. So that when I apply the operation, this will be much easier for me to draw the geometry for decomposition of the geometry of the circular cylinder with a 30 degree sector. So unsuppress. This is where I have placed this one. Okay. And but just be careful that when you are defining the axis direction, the direction should be correctly defined. It should go on the plus y-axis. Okay. And angle should be correctly done. And then what I did is that I made the two more sketches on the xy plane. Okay. The one sketch is at the I tried different angles. I started with the 50 degrees angle from y-axis of the one line, and then I made the constraint here, and that constraint is a symmetric constraint which I applied on these two lines. The symmetric constraint or symmetry constraint. So this line and this line will be having same angles. So there's no need to define the dimension like angle for the both of the lines, but for only one line, and then put the constraint for the symmetric boundary condition. And also I defined the height of this point from the x-axis. Okay. And the angle I found that if I use the 50 degrees, 45 degrees, so this will not produce a good mesh because the sector size is 30 degrees. So on the both sides are 30 degrees. So 30 degrees angle will produce the best results, best mesh. So that's why 30 angle is given there. Okay, finally. And then I use the first extrude command, and in the first extrude command what happened is that this should be closed sketch. So this should be a closed geometry, and please note that the sketch number 6 is different. That is over here. So I can hide it. And now you can see this sketch is over here. Okay, this sketch. So it should be closed sketch, and then in the extrude command what I did is that I used the slice material and I made a length of 50 meters so that it will cross whole geometry. So slice material and through the whole geometry of the circular cylinder. So this will make this body on the bottom side, this body, and one body will remain here. Okay. Okay, then I made the another sketch, and that will take the first point from this point onwards. Then I made the one vertical line, exactly vertical line. It should be passing through the center of your geometry. And then I made another line. This angle is not an important part. Okay, so I made another line going in this way. And then I made another line, and that line actually was going through the same angle as angle of the sketch number 5. So on this side, okay, same angle, and it should go outside. And then I joined this line and this line with a straight line. So what the dimension of these lines or angle of these lines is not important. It should be outside. That's important. Here this line and this line, they should be exactly on. So either you can put the angle here with the y-axis, or you can just align with the line over here, and this line is vertical line. Okay. So again I use the extrude command with the same option like slice material, 50 meter length, and that's all. So this will actually you might be wondering that this will subtract the only one body. So definitely it gets you the one slice here. So remaining will be third slice. Okay, this is the point. So now you have the 3 bodies. Okay. The last thing is that you, because the symmetry like a periodic condition was already there, and so here uh, these conditions, symmetry and the after symmetry we have periodicity applied. So this is still there. Symmetry is like a not for symmetry, but symmetry is a command. If you export symmetry, then it will export symmetry commands like export symmetry surfaces. But if not, then it will only export the this sector geometry to the ANSYS meshing or some other meshing software. So then I have to like subtract these geometries into multiple parts. And then finally from the multiple bodies I have to form a new part. Okay, so I selected these 3 parts, right click here and I form a new part. Okay, so this is same as we did in the case of sweep meshing. So from the 5 bodies we made the 1 part. Okay, after that I have gone through the meshing. Okay, so you have to click on the green tick mark and close it. Okay, this is the geometry we have here. Okay, so what I did is that I changed the method to the sweep meshing because I copied the tetra meshing method, that container, and the edge sizing I put are like similar to the 3D case, 50 cells along the length. Okay, it is a hard, behavior is a hard, and edge sizing second. This is important. So this here I put the number of cells 7, although by sector size. Because in the 360 degrees we have the 40 cells. So if I divide the 360 degrees by the 40, I should be having like 9 cells there. Okay. So no, sorry, for 10 degrees the 90 degrees, for 10 cells for 90 degrees. So for 30 degrees it should be like 3 cells or 4 cells. But then 4 cells will not be enough. So I put the 7 and 7. So this will be the like a 14 divisions. Okay. And same goes over here, because this mesh will go on this edge and then here, and on the right side this will go on this edge and then go on the opposite side. And then edge sizing here, this will be for diagonal edges. Here I put the 20 cells, and the behavior is hard and biasing factor is 3, and 3 reverse biasing are applied. Okay, and if you generate the mesh, number of cells are very less, like a 17,000 to 20,000. It's 16,450 elements are there only. Okay, and this is like because of the control we have in the hexa meshing, especially on the lateral direction, lengthwise direction. So we could control the cells here, and it's not important to have the very fine mesh here. But tetra meshing, if I reduce the size and along the second dimension, like here, it will also reduce the mesh, like mesh elements, and mesh elements will be very big, and it will not represent geometry in a proper way. So that we couldn't do. Okay, so here the quality is also very good. The minimum orthogonal quality is a 0.5, and the maximum is a 0.99987. Average is a 0.87. That's a very good. And last thing is to update the mesh. Okay, and one more thing is that in the connections there will be contacts. Please right click, not go to the like a subset, like every contact here, region here, but right click on the contacts and then delete it. Okay, very simple solution. Okay, so you can save the project file here, and then go to the setup. So we will do the same thing here, like we will be making the, here we don't need the mesh control, because although I could use that mesh control, if needed you can use it. But here, because in the hexa meshing we have the exactly control on the sizing and everything